So first off, concussion is also the same as a mild traumatic brain injury. It just depends on the literature you're reading. If you're reading more neuro literature, you're going to see the term mild traumatic brain injury. If you're reading sports literature, you're going to see the word concussion. They're effectively the same thing. And it's due to stretching and shearing of axons. It's not coup contra coup. The old idea was concussion was because the brain bashed up against the inside of the skull and then bounced back and hit the back part of the inside of the skull. So you'd have this coup contra coup. They thought it was more of an injury to the outer cortex. And what we know now, based on all the science that's come out over the past, 15 years or so, is that that's actually not the case. It's actually a white matter injury. So it happens to the deeper structures of the brain, not the cortex, and it's due to axons being stretched and also sheared across each other. Now I have this cross-sectional image of a brain. The white matter obviously is in here. It's white because it's lined with myelin, which makes, that's a fat, so it's white. And then the gray matter is the outer cortex here. Now these two tissue layers, white and gray, are different densities. So when you get hit and your brain undergoes acceleration, deceleration, those layers actually accelerate and decelerate at different rates because they're different densities. So what you get is a cross shearing between those two layers, and you also get pulling apart because one will move before the other and then it'll pull the other one through, so you get this stretching of axons. Now if we watch this little kind of GIF here, you can see that when the brain gets hit, there's this kind of fluid wave that happens. And when that fluid wave is happening, you can picture every little axon getting stretched as that happens. Okay, so that's actually what a concussion is. It's that initial stretching and kind of cross shearing between those two layers. So there's two phases. The first phase is the excitation phase. This is going to cause your initial signs or symptoms. So somebody gets hit, playing a sport, you see them get up, they're staggering, they're off balance, they don't know which direction they're going. That's the initial kind of concussion signs and symptoms that people might experience. Typically, though, that goes away within seconds to minutes. And then the person comes to the sidelines and they're like, I'm fine. Okay, right? But the concussion has already occurred. And the second phase is coming. The second phase is called spreading depression, and this results in an energy deficit because of that initial phase actually causes disruption in our ability, in our cells' ability to produce ATP. So it messes up our mitochondrial production of ATP. So let's break this down. So this is the excitation phase. So if we picture an axon as kind of a long tube, right? But it's not actually a long tube, it's actually porous. There's little holes in it. Now those holes are tiny, so tiny that things don't really get in and out. But when acceleration happens and that axon gets stretched, well, now those holes, those pores, get stretched and pulled open as well. And if we remember our concentration gradients, we have high amounts of potassium inside the cell, we have high amounts of calcium and sodium outside the cell, right? So things want to go where there isn't as much of itself, right? It wants to go down the concentration gradient. So as soon as those pores open up, boom, now you get a bunch of potassium leaving and you get a bunch of sodium and calcium flooding in. Well, what's that going to do, right? That's going to cause an action potential, right? We have our resting membrane potential at negative 70 millivolts. As that membrane potential gets more positive because of this ion exchange, boom, action potential. So you can think about concussion simplistically as millions of brain cells that all at the same time think or get tricked into thinking that they've just received a signal and they have to fire. So now you get millions of brain cells all firing. So you get this electrical storm that happens inside the brain, which is why the patient can't make sense of what's going on around them.